Hi everybody, I'm Scott Stanchfield. Let's set up our Android development environment called Android Studio. The first thing we need to do is download JetBrains Toolbox. This is a really convenient application that lets us manage multiple versions of either IDEA or Android Studio. So if you already have an Android Studio installed, it can coexist with the one we're going to use for the class. So I'm going to go ahead and download this. I'm running on Windows, so I'll download the Windows version. And once that's done, I'm going to click on it to run it and install it. And I'll go ahead and say run JetBrains Toolbox. Now, when I initially run it, it's going to install itself as an icon on my system taskbar over here, or if you were on Mac, you would have it on the system menu. I'm going to hit finish to go ahead and run it. And we'll see that we have the little pop-up here. It's going to come up automatically. Go ahead and hit continue just to kind of walk through accepting the license agreement and all that type of stuff. And poof, there's our JetBrains Toolbox. Now you can also get to it just by clicking on that little taskbar item. Boom, there it is. So what we're going to do is we're going to scroll down until we see Android Studio by Google. Now note that it doesn't tell you which version here, so what you can do is go over to this little ... and then choose Available Versions. And this will show you all the versions that you can download. Make sure you choose the version that's described in the class documents. I'll tell you which version to use. For this particular demonstration, I'm going to be using Hedgehog Beta 1, and I'm going to hit install. And yep, I have read it and agreed. I'm going to install Android Studio, and that'll take a moment. I'm going to pause the video while it goes ahead and installs. And poof, it's now installed. So I'm going to go back to the tools page here. And if I go up to the top, you'll see that Android Studio is installed and it's congratulating me. So I'm going to go ahead and click on Android Studio to run it. It's going to first of all ask if you want to import settings from a different version of Android Studio. I'm going to say do not import. If you already have a previous version, feel free to import it and keep your settings. And there's our cute little hedgehog. And it's now going to ask you, do you want to help improve Android Studio? And at this point, you can choose to send usage statistics to Google or not. The statistics are actually very, very useful. I've been using them to take a look at templates that are used inside Android Studio and try to see how popular certain templates are, so we can make some recommendations on which templates to remove, which templates to keep. So I'm going to say send usages, but this is completely up to you. Don't feel you have to do it one way or the other. Okay, now the setup wizard is going to walk us through just setting things up. I'm going to hit next. And you can either choose standard installation or custom. I always like to go to custom just to kind of see the options as I'm going through. And here is where we're going to be choosing where to place the Android software development kit, as well as what we want to download. Now, on this machine, it's a Windows machine, you have the option of downloading HAXM, which is a hardware accelerated execution manager, which will help run the emulators much, much faster. Now, depending on the version of Windows that you're using, you may also see, and depending on the hardware you have, this Android emulator hypervisor driver. Take whatever is selected by default, basically select everything, you should be in good shape. Now, the default SDK location on Windows is under App Data Local under your user directory. On the Mac, it's under Library Application Support Google. Actually, I'm sorry, Library Application Support Android. We'll hit next. Now this is going to tell you how much memory you're reserving for use in the emulator when the emulator is running. So in this case, I'm going to have it go ahead and allocate 4 gigabytes. That's a perfectly reasonable amount. Now, if you're really low on memory on your machine, I recommend that you try to get a physical device, so some kind of phone. And you can get some fairly inexpensive phones nowadays, usually some of the prepaid phones where you have to pay monthly in advance. Usually those will work really well, and a lot of them are under $100. So I'm going to hit next, and that'll make your development go by a lot faster. If you have a good amount of RAM, I've got 32 gig, for example, that's going to be plenty to run an emulator. 16 gigabytes, depending on how your system's configured, may be enough, might not be enough, but it's something to kind of play around with. 8, definitely not a good idea. Okay, so it's going to tell us all of our settings. I'm going to keep hitting next. And when it comes to the license agreement, you're going to have to select each of these top level licenses and then check accept. So I'm going to pick that one and pick accept, and then this one and accept, and hit finish. And now it's going to download all the software that we requested and unzip it. Once again, I'm going to pause the video while this happens and see you in a minute. And it's done. Now you're seeing a failure message here because I already have HackSim installed on this machine. I forgot to uninstall it before running this demonstration. I'm going to go ahead and hit finish and pretend that that never happened. So now here we are inside Android Studio. We'll see that we have this little welcome screen, allows us to create a new project, open a project, or fetch a project from a version control system like Git or something like that. So what we're going to do is we're going to go ahead and hit new project. And this is going to give us a bunch of templates that we can use. We're going to stick underneath this phone and tablet, and we're going to always create our projects based on empty activity. Empty activity creates a single screen that's going to host your Jetpack Compose user interface. All these other ones that say something views activity, these are using an older system of how we create user interfaces on Android called views. We're not going to be using any of those. The last two in here are for C++ development. So if you're trying to create a C++ application on Android, or if you're trying to create a game, you might want to use one of those. So we're going to choose empty activity and hit next. And now we get a chance to change our application name. Now notice the relationship between name and save location. Whatever you type up here for the name is going to be used at the end of this save location. But a little gotcha here. If you change this save location, it's going to take that as the absolute directory where you're placing your application name. Now, if the base, the parent directory here, is correct for you, and this is actually a reasonable place to put things under this Android Studio projects directory. If that's okay, don't modify save location. And then as you change this, say application 1, you'll notice that it changes it underneath save location. If you don't like this location, you can go ahead and hit the little open button here and choose where you want to put it. So let's say that I create a new directory here, and I'll just call it foo. How about that? That's a great name. Note that now it says foo is the directory where application 1 is going to be stored. If you change this one here, make sure you type in your directory for the application itself as well. Now I'm just going to change that back to Android Studio projects. Whoops. That's where I'm used to seeing it. And might help if I actually created a directory like that. There we go. And then once again, grab that original name and paste it on the end there. So that's our name and our save location. If you want it in Android Studio Project, don't mess with the save location at all. It'll do it right. Now the next time I open this, it's actually going to use this as the base and then put in the name, so we should be okay the next time around. The next thing to take a look at is this package name in here. This is going to be a unique identifier for your application on the Google Play Store. You want to make sure it's going to be a unique identifier. So what you do is get a hold of a domain name and just swap it around. Now, for example, I own javadude.com. So I would call mine com.javadude.something. And of course, if I were doing it for something at Google, I would say com.google.something. So that'll take care of that. For your assignments, what I want you to do is use your last name and then your first name and then the application name. And in that case, for the assignments, all the applications are going to be HW1, HW2, HW3, and so on. And so we would have these kind of looking like that. Now for the minimum SDK, once again, make sure you check the course materials on the course content site. It will describe what minimum SDK to use there. One little thing I do want to point out here is this little Help Me Choose button. When you're really creating an application, what you're going to want to do is take a look at this Help Me Choose and see the distribution of the versions of Android that are being used. And some of these older ones, there still are people using them, but not that many. The vast majority are using Q or higher, 72%, 84%, 90%. Once you start getting back to Oreo, you're not going to lose too many people. And the trade-off that you have here is between what features you want to support in your application versus what you want to actually have to emulate in your application or fall back to. By choosing a later version, you'll get all the support that's listed underneath the version when you select it over here. For example, in 23, they introduced runtime permissions over here where it says runtime permission management. And that was a huge change in how you have to write your application. So if you choose at least 23, it's going to make your life a little bit easier because the runtime permissions are there and you don't have to do any conditional logic on whether you should actually try for runtime permissions or not. And you'll notice here that that's going to cover 97.7% of your users. Those numbers are coming from the Google Play Store. So that's based on how many devices have been checking in with the Play Store for people to download applications. And then it keeps track of how many are for each version. This will give you a decent idea of your reach in your application. So I'm going to go back to 24, which is what I was using for this class. And then at the bottom here, where it says build configuration language, one thing that I want you to do is change this to say Kotlin DSL plus Gradle version catalogs. And at some point that will be the recommended way, but we're still in a beta for this particular version that I'm demonstrating. So we're not officially recommending it, but version catalogs are really the way to go. And I'll show you what those look like a little later. And we'll go ahead and hit finish. And that creates our application. Now you're going to notice at the bottom of the screen, you're going to see several little messages popping up here and some toolbars. But before we go to that, let's talk about this guy who just popped up. So this little notification, you're going to get this on Windows. It says Microsoft Defender configuration. It's detected that Defender is enabled. So if you have that Microsoft Defender enabled, you're going to get this message. And unfortunately, there's no way for Android Studio to be able to see what you've excluded based on permissions on your machine. So this message is going to come up for every project until you explicitly get rid of it. And it's a really useful message because you're going to see down here it's going to list some paths that it recommends that you exclude from your virus scanner. So if you're able to exclude paths, I recommend you exclude these paths. Down here, this automatically button will be able to take care of it if you have administrator rights and there's not a policy in place that's going to stop you from using that. I'm going to go ahead and press that in a second here, but the places we're going to see here are the Gradle distribution and any type of caches for Gradle, and Gradle is our build language we're going to use. The project itself that we're dealing with, the SDK for Android, and the settings directory for your Android Studio installation. If you don't have these excluded, what's going to happen is during your build, it's going to generate thousands of files. These are going to be the results of different types of builds. They're going to be transformations happening. There'll be jar files that are pulled down from the internet. It's going to really slow you down if you don't have those excluded. So I'm going to go ahead and hit automatically and then cross my fingers. It's going to work on my machine. And it's going to say, do you want to do it? I'm like, yep. And then it comes back and it says paths were successfully added to your Defender exclusion list. Now, what I typically do is I go in and I tweak those settings so that it's going to have the parent directory that I put all my personal projects in. And that way I don't have to keep adding for every single project. When you do create a new project, though, it's going to still ask you again, hey, please make sure you have these directories excluded. And there's an option on there that you can just choose to say, don't remind me again for this project. I'm going to go ahead and hit X there. There's a little what's new for each version of Android there. I'm going to get rid of that. And let me expand this to full screen so we can actually see this a little bit better. Now at the bottom, you're going to see all these messages saying it's downloading files, it's creating a build model, and so on. Right now it says importing library data. What happens here is Android Studio is trying to figure out what your project looks like. So what it's doing is it's running some Gradle build tasks to figure out the build model for your application, and then it's going to store that in some metadata directories for Android Studio for your project. This allows it to provide content assist and other type of tooling based on how your project is organized. So we need to let that all finish before we can actually do anything. One of the things that it's going to do is any jar files that are referenced as dependencies, they need to be downloaded, and then it's going to index them to figure out what symbols are inside those. That's how it can do content assist. That can take a little while. It's usually for the very first project that you import, it's going to take a lot longer. After that, it's already got a lot of those installed in the Gradle cache. It's got the Java JDK installed. It's got the Android SDK installed and knows all their symbols. So what I'm going to do is I'm going to again pause the video while this finishes. Oh, hey, it looks like it's almost finished. I might not have to pause the video. I might be able to just keep talking. Well, now he's indexing dependencies. So I'm going to pause the video again. Notice how it's indexing the JDK, and we'll come back in a moment. And that only lasted about 20 seconds after I paused the video. So it wasn't too bad, but then again, I have a really fast internet connection and crazy fast hard drive on this, well, SSD on this machine. So your mileage is gonna vary based on your internet connection speed, what type of storage device you have, things like that. Okay, so now we're imported. Everything is set up in our environment for us to start coding. I'm gonna go ahead and dismiss this. The first thing I like to do inside here is go over to this section here where it says Android at the top. This is called our project view. And I really don't like the Android display that they use for this. There's a bunch of different layouts that you can display this tree in. This one is trying to be helpful by organizing things in a way that might be useful for Android development. Unfortunately, there's some files it doesn't include, and it doesn't structure it the same way as it's structured on disk. I like to just look at the structure on disk. So if we go up here and click on Android and change it to project, this will show us exactly what we're seeing on our drive. So I'm going to go ahead and expand this, and let's talk about a few of the things we're going to see inside here. Notice this application directory here is bold and has a little icon on next to it, a little green icon. This is called a module. And that's going to be our main application module. It's going to be built for our project. The rest of these files are all considered part of the project root. So this is basically general configuration for the project, and then you'll have one or more modules that you're going to build. Let's take a look at our top level here for a second. Up here, this .gradle directory is a downloaded copy of the actual Gradle machine. So it's the Gradle executable itself. .idea is metadata for this environment for this project. Again, this is our application module. And then Gradle is our definition for our project of which version of Gradle we want to download. And what they did with Gradle was really kind of clever. If we expand this up here, we're going to see this folder called wrapper. And one little note I'm going to say right here, I'm glad it came up here. As I was clicking on that, I dragged it slightly, and now it's saying, do you really want to move that? I don't like this. So what I'm going to do, I'm going to hit cancel. Let's go and take a look at File, Settings. If you're on the Mac, you're going to go up to the System menu to the Android Studio menu and go down to Preferences. And underneath here, what I would like to do is, let's see, where is that one set? It's actually under Appearance and Behavior Appearance. Over here where it says Drag and Drop with Alt pressed only, I really like to check that option. That sets it up so that I can't accidentally drag things. I'm going to go ahead and hit OK on that. And poof, now if I do a little bit of a drag, no problem at all. Anyway, where I was. Underneath Gradle, there's this wrapper directory. And the wrapper directory has a Gradle wrapper jar. And at the top level, you'll see this Gradle W, either for Linux or the Mac or for Windows. These scripts and this jar are a really small stub. And what will happen is when you run Gradle W, this stub will look at this properties file to download a version of Gradle. And if we take a look inside this Gradle wrapper.properties, we'll see here that I'm saying download Gradle 8.2. That's just the default setup for this version of Android Studio. And so this is a way that when you distribute your project to someone, they can say Gradle W to build their project. It'll automatically download the tools, the actual Gradle executable themselves, based on this version that you're saying, I'm building with version 8.2. That sets up a really consistent build environment for you. And then that way somebody else doesn't need to have pre-installed Gradle on their machine in order to be able to build it. So kind of a nice setup there. Now, if we go a little farther here, we have this libs.versions.toml. That's in that Gradle directory. This is called our version catalog. And if I go inside there, we're going to see that it's a file that describes the versions of third-party dependencies that we want to use inside our application. So there's a couple sections in here. We have versions, libraries, and plugins. At the versions, we're just defining some variables that we can use down here. Now, you don't have to use the variables for these guys. So where it says version ref, that's referencing a variable up there. You could just directly say version equals some number, but it's really nice to have this separate block of version variables that you can modify and keep track of in one place. And then also you can use the same variables in multiple places. So inside here, you're going to see a couple little yellow underlines here. So for Activity Compose, it's saying that this version, if I float over it, a newer version is available, 1.7.2. So what I can do is click on it and hit Alt-Enter, and then say change to 1.7.2. Boom. And I'll do the same thing with the Compose bill of materials here. And what the Compose bill of materials is he is an artifact that's sitting in a repository somewhere online. That'll get downloaded that contains all the versions for our Jetpack Compose dependencies. Jetpack Compose is the user interface toolkit that we're going to be using for this class. Now you'll notice down here, there's a bunch of dependencies that say AndroidX.compose, and they don't have a version specified and don't use a version reference. The way this works is when I bring in this compose BOM, and we'll see where we bring in him a little later, he loads all the version numbers that are set to work together. And basically what we do is we take a snapshot of the current state of the Jetpack Compose executables. What's the latest version of each of those? And they may be very different versions for all of these guys here. This allows the different teams at Google to develop different parts of Compose on their own timelines without having to try to coordinate a single release for a single version. So these guys down here, because they're listed inside the BOM, will have the versions available to them. So these are third-party libraries that we're going to compile our code against. Now down here, plugins are actually pieces of code we're going to use as part of the build process. So we have here the CommAndroid application plugin, which will build an application for Android. And his reference here is AGP up here. So right now this is using 8.2.0 beta 01. Our Kotlin plugin here is going to let us use the Kotlin programming language to develop code in our project. So that's our version catalog. And by putting it underneath Gradle libsversions.toml, you don't need to do anything special to pull it into your project. So we're going to go down to the bottom now to this settings.gradle.kts file. And if we take a look in here, first of all, let's go down to the bottom of this. He's saying which modules I want to build as part of my overall build. So I mentioned this application module. By putting this include here and then synchronizing with Android Studio, Android Studio will know that's a module and highlight it for us. This is just our application name. And then the rest of here is just setting up which repositories we want to look online for our plugins and for our third-party libraries. So first of all, at the top, these are the repositories we're going to go and fetch the plugins from. Those are those two plugins that we mentioned before, the Android application and the Kotlin plugin. And then these are where it's going to find all of the third-party libraries that we're going to be compiling against. These warnings here, if I just float over this, this just says that these are incubating. The API in these isn't quite stable, so you may have to change that with a later version, but this is actually the code that you want to use. Okay, so we'll notice at the top here, this little blue bar, he's telling us that the Gradle files have changed, and those were those version updates that I did. So I'm going to hit sync now. If you don't see that, or if you're not inside the file, you can always go to the little elephant icon here with a little arrow, and that'll sync the project with its Gradle files. I'm going to go ahead and hit sync now. Notice that it's pulling down different versions now based on the updates that I just did. Hopefully by the time I'm done talking about things, that'll be done. Now let's take a look at a few of these other guys here. Local.properties is something that you normally don't check into your version control system. This is a file that we're using right now to describe where the Android SDK is located on your machine. And we'll see here it's under my app data local Android SDK. Go up a little farther, we have these are the different Gradle W's to actually run Gradle and pull it down. Gradle.properties are some settings we're going to use inside Gradle. And we're going to be using the official Kotlin style Android X. We're setting up a heap size of 2 gig for each Gradle daemon that's created. And I'm not going to get into the non-transitive R class I may mention that at some point. Okay. Now this is the main build.gradle, the root build.gradle inside your project. And if we take a look at him, he's not really doing much there. He's just saying which plugins and those versions of those plugins do I want to use inside my project. So this is normally what you'd see. There's a bug in process to make us not have to do this DSL scope violation thing, which will make this be removed as well. So unfortunately, we're in a little bit of a weird state here with this bug, but once it's fixed, we should be a little bit cleaner up here. So this guy is going and pulling in these guys from the version catalog. Let's take a look at that version catalog one more time here. I'm just going to drag, hello. Split right. I thought I could drag him, but apparently not. So now we're going to see that libs.plugins.android application, if we take a look at it, this overall file is called libs. The plugins section is here, and then Android application is here. Note with these other names like UE-tooling, that dash is going to be replaced by a dot when you use it as an alias, and we'll see that a little bit later. All we're doing at this top level is saying, hey everybody, here's the version of the Android application plugin we're going to use and the version of the Kotlin plugin we're going to use. By saying apply false, we're not actually activating those plugins at this point in the code. All we're doing is pulling them in so that we know which version they're going to use, and then all the submodules just have to mention the names of those and they'll have the correct version. So let me come out of there, and if you see my mouse doing weird things, I've got a little bar on the screen that's keeping track of the status of Camtasia that you can't see, and I keep having to drag it out of the way because I'm dragging it to bad spots. Okay, so that's really our top level. There's also a git ignore that it generates for when you're checking things in, which things not to check in. Let's take a look at our application now. At our application level, let's take a look at his build.gradle. And this is really where all the magic happens. So inside of here, you're going to see that I'm saying plugins with these alias names. I'm not saying apply false. So it's actually going to activate those plugins as part of my build at this point. Then I'm going to configure my build, and you'll see there's a couple sections in here. Android and dependencies. And for the Android configuration, this is us configuring this Android application plugin. So I have this namespace. This is where we're going to have several pieces of generated code are going to be generated inside of that package. I have the SDK that I'm compiling against. This is the Android SDK. The minimum SDK, so this is as far back as I want to support, and then which one I'm planning on targeting so that it knows which versions of the API should be available. The application ID is that unique identifier from when we're deploying to the Google Play Store. Version code and version name, you need to update these if you're deploying to the store so that it will know if the user is up to date or not. We'll talk about tests in another module later on. And what Vector Drawables does here is if we have a SVG that we're using inside of our application to draw a piece of graphic on the screen, this, by saying use support library, will generate actual images based on those SVGs that can be used in versions of Android that didn't support SVGs. Okay, we'll go down a little farther here. This is just setting up how we want to actually build our release application. These compile options and Kotlin options are telling us when we're building Java code in our application. Now for this class, we're just using Kotlin, but if you had any Java code, this is saying which level of Java to allow in the application and which level of bytecode to generate in any jars. For Kotlin options, this is telling us which level of Java bytecode to generate when Kotlin is compiled for the Java virtual machine. Now these two options I don't like using because there's too many different variables we're specifying here. And it also doesn't handle a couple things. There is an option called the JVM toolchain. And if I come up to the top here, I can say Kotlin JVM toolchain 17, for example. And this will act as the default for all three of these options. So what we're going to do is put this guy in for the JVM toolchain, and then we're going to get rid of compile options and Kotlin options underneath Android. Boom, away they go. Now there's also a couple other things that the JVM toolchain does. This is the version of Java that's actually used to compile any Java code, as well as build any Java docs that you're using in your application. So this is really the one that runs those. It also is the version of Java that's used to run any unit tests that you have defined in your application. So it's really useful to put this up here because you can then specify which Java version is required to do all that for you. Behind the scenes, there's some resolution being done to see, do I have a version of Java installed that supports that? And there's certain options that you can specify in this file to be able to have it automatically download this specified version. I'm not going to get into those details. If you want, take a look at the Gradle documentation for how to set that up for automatically downloading. So that simplifies things here a little bit. We're now also going to say which build features we want to support. And what this will do by saying compose equals true, this tells the Android Gradle plugin to support compiling Jetpack Compose inside your application. And what we're going to do in our applications, we're going to add some annotations to our code to tell it that this is a compose function. And the Android Gradle plugin is going to run a Kotlin compiler plugin to actually change some of that code on the fly. So this feature triggers that for us. This guy here is the version of that Kotlin compiler plugin that's going to be used to actually create Jetpack Compose code. Okay, so let's go down a little farther. At the bottom here we have dependencies. So these are going to be any third-party libraries that are available to our source code in this module. And we'll notice that there's a couple different types here. The first type are implementation dependencies. These ones are going to be used for the code that we're building and the code we're going to be deploying. Test implementation is going to be used for any type of JUnit tests that we're going to be running. Android test implementation is going to be used for Android instrumentation tests that are going to be running on an actual emulator or physical device. And then debug implementation are libraries that are only included in the debug version of our code. Now, likewise, you could also say release implementation, which would be for things that are pulled in for the release. Now, there is one type that we're not seeing here, and that's if I said API and put in some library that I'm going to use there. API says that for this module, I need to depend on whatever that dependency is, but I'm also going to expose that dependency to anybody who uses this module. So if I were developing a library and I wanted to include something else and expose it as an API, I could use that. I strongly recommend you don't use that as much as possible. Anytime you use that, it's going to make your build a little bit slower because if something changes, you may have things down the line that need to be updated as well, recompiled as well. So typically, use implementation most of the time there. So that's our build file at this level. Let's take a look at some source code. This libs directory, by the way, we can just delete. You can, if you want, drop in some jars there directly, but then you'd have to specify a dependency implementation that says pull them out of that libs directory. Try not to do that. Go ahead and have those dependencies be pulled down from those online repositories. Okay, so now under app source, these are what are known as source sets. And these are different groups of source code based on the configuration that you're trying to build. So we'll see here we have Android test, test, and main. Android tests are what we call instrumentation tests. These are tests that are going to run on a physical device or on an emulator. Test are unit tests. These are just going to be run on a Java virtual machine. They'll be very, very fast. The emulator ones are going to be slower. Main is actually our source code that we're going to be developing. Now, there are some options you can set up if you want. You could have some alternatives here. We could have maybe a configuration we call free, which might be for a free version of your application, versus another one which might be called paid. And we could have source free and source paid sets inside here that has just the code that's different from main based on those configurations. Now underneath main, we have a directory called Java. Now this might be a little misleading because you're going to see we have Kotlin files underneath Java here. The Java directory can contain both Java and Kotlin. If you had a source main Kotlin folder, it could only contain Kotlin code. So typically, you go ahead and put all of your Kotlin inside Java. If you really want to, though, go ahead and create a Kotlin directory underneath main and put your Kotlin code in there. Underneath that Java directory, we have whatever packages we want to create. So I could right-click on this directory and say New Package and specify a new package to put inside there. And underneath there is where our actual source code is. Now here we have under UE theme some source code that was generated for Jetpack Compose to have a theme on the screen. So it's going to be what colors you're using, what typography you're using, things like that. For our main activity, which you see here on the screen, this is defining the screen that you're going to present to the user. And I'm not really going to go through the code on this right now. That's more for when we talk about Jetpack Compose. But in a nutshell, what we're doing here is main activity is a screen on your application. And for Jetpack Compose, we typically only use one. We'll have one screen. Underneath there, we just have calls to what we call composable functions, which are functions that describe a user interface. So what we're doing is we're declaring the user interface we want to put on the screen. We're not actually doing drawing at this point. So we declare it. Once the declaration is done, Jetpack Compose renders it on the screen, and life's peachy. And we'll talk about that a lot more when we go into detail on Compose. Let's see how we run this guy. Well, before we do that, let's do one more thing here. This resource directory. These are different resource files describing things like things you can draw on the screen, image files that you want to display, strings that are going to be used to localize your application, things like that. And underneath here, you'll notice that you have directories that have these little extensions on them, like MIPMAP NE, MIPMAP HD, MIPMAP MD. Each of these are associated with a configuration on your machine, or sorry, on the device that you're running. So if I said something like values-land and values-portrait, that would be for landscape mode or portrait mode, depending on how you're holding your device. And anytime you change that configuration, so if you rotate the screen and the auto rotation is turned on, it's going to refresh this main activity. Basically, it throws it out and recreates a new instance. And then it chooses any of the resources when you ask for them based on that device configuration information. We're going to be using some a little later on down the line. I'm not going to go into details on it. But the one thing that I might want to mention right now is you notice under values we have strings.xml. These are any type of user-facing strings that are constants inside your file. And these ones you may want to put into different directories like values-es for Spanish, values-en for English, different types of language extensions so that depending on what the user has set on their device, they can get your different translations. Then underneath each of those directories, you just have a strings.xml, put the appropriate translations, and you're good to go. It'll automatically pick those up. Pretty neat stuff. Okay, so I'm going to pop out of there. Now I think we're ready to run this application. Well, almost. One more that I want to talk about here. Under source, main, Android manifest. This is the file that describes your application to the Android system. So when we take a look at him, we're going to see in here, this manifest says, I have an application, and here's the details. I have inside of there an activity. This activity, called main activity, has an intent filter. And the idea behind an intent filter is this is a way to catch requests from the system. So in this case, we're saying main launcher, which is a special request from the system saying, I'm opening something from the home screen. By defining this intent filter here, this actually puts this activity on the home screen of your application. And then when the user taps on that home screen, it'll send off what's called an intent, describing that it wants to run your application. This says, go ahead and catch that intent so I can run my application. In old versions of Android, like really early on, you had multiple activities in your application, and you could jump between them by using intents. You registered all the activities with the Android system. From one activity, you say, hey, system, Here's an intent describing what I want to do. So it'd say I want to go to a different activity. And then the system comes back and looks at the other activities that were registered to see if there's a match, and then goes there. We'll talk more about that when we're talking about legacy, the views system later on. Okay, now we can run this. So once everything is set up here, if you ever see any of this Gradle files have changed, make sure you sync. I'm going to go ahead and sync again here. Okay, that's good. And now I'm going to take a look up at the top here. Now we'll notice here it has this Pixel 3a API 34, blah, 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 blah. This is the device that you're going to be running on. And when we actually set up Android Studio, we had it create a virtual device for us. If we come over here to the device manager, we can take a look at the definitions of those virtual devices. So I can come over here and go to Edit, and this will describe that device. If I went and chose this plus up here, I can create a brand new virtual device, changing the size on it, changing the API level that I want to support, and so on. I could also plug in a physical device. And we'll look at an example of that a little bit later. What I want to do right now is I'm going to go ahead and run this virtual machine. I can just run it from here by hitting the play button, or when I run my application, it'll automatically start it up to run on this device. So I'm just going to go ahead and run it manually by clicking on it. And I'm going to pause it until this actually starts up. And there we have our device. Now this is an emulated device that I can run my application on. Let's talk about how this Android device works. So if you're not familiar with Android, I'm just going to hit a couple points here. First of all, this is the home screen. You could have applications on it like we have right here. If I click on Chrome, for example, it's going to open up Chrome, ask me some questions to configure it. I'm just going to say use without an account for now, and so on. Nope, don't make life easier for me. Boom, now we have Chrome. And we will come out of there. Bomb threat at the zoo, that's not fun. So now we're inside the device. Let's take a look at a couple pieces. Up here we have the status bar. Over here are some little icons with notifications that are active. And over here are some status icons. If I drag down from there, that's going to open up my notification pane here, showing me what those notifications are. If I click on notifications or click on the little drop down here, it'll expand them so I can see more information. Sometimes there'll be options like up here, virtual SD card. What do you want to do? Explore or eject, that type of thing. I'm going to go ahead and clear those by hitting X. Not necessarily all will clear. If I come back in here, you'll see that this one stays here. Some notifications are persistent. They will stay. At the top here, we have some quick actions. And if I drag down some more, whoops, it's really hard to do this on the emulator. There we go. We'll see the different notifications that we have up there. Okay, I'm going to go back up here. Now, as far as gestures are concerned on here, we can always get to the home screen by dragging up from the bottom. We can go back a page by dragging in from the side. And again, this is very difficult to do on an emulator, so they have some options at the top here. Here's our back button. This goes to our home screen. And then this shows all of our recently opened applications. So if I had the camera open, and I'm going to go ahead and use the permissions there to say, yep, that's cool. And then I'm going to go home, and I'm going to open up Chrome. And then I'm going to go home, and let's open up the phone application. So now if I go to Recents, which I could do by dragging up from the bottom and kind of holding in the middle until you see these other guys come up, now I can actually switch to other applications that are active. And if I want, I can clear them by just dragging them up or hit the Clear All button. Most of the time you don't need to do that. You can just leave them going there. It's not actually running them. A lot of those have just kind of been frozen in time. So when you click back on it, it'll reopen the application at that point. Now, the gestures being difficult to do, you can use those three buttons there, especially the back button, or you can change the settings on this device to actually use the system navigation bar, which would appear at the bottom, and it'll give you those three buttons. I'm not going to go through that. If you want to, you can configure it that way. Now, if I wanted to set up a physical device, there's a few things I need to do on the device first to enable the debugging and all that. Let me show you how you do that. I'm going to do it on the emulator here to kind of show you how the process works for the part that you can't see. Otherwise, I got to bring a separate camera out, and it's a whole thing. So I'm going to go down to settings by dragging from the top and then dragging a second time, and you'll see the little settings icon appear. You could also, if you want, go to the application list by anywhere in the middle of the screen here, just kind of dragging up. Whoops, dragging up. This gives you your application list for everything, and then click on settings. Both of those will get you there. Now what I'm going to do here is I'm going to say, oops, I can't go to developer first. I'm going to go to system settings. So go to system, and underneath there, this is a little different on each system. So that's probably not the one that I want to look at. Let me go to the top level. Sometimes it'll be under system settings, but let's go down here, usually near the bottom, and about, so it'll be under either system or about emulated device. You're going to go inside there, and you're going to look for build number. So you're going to see that under system, or you're going to see it under about emulated device, or about whatever device you have. And you're going to click on this one 7 times. 1, 2, 3, 4, 5, 6, 7. And it says, poof, you are now a developer. And what this does is this is a kind of a little not so secret way to hide the developer options menu. So you need to click on the build number 7 times. Now we'll come out of here, and now we can do under search settings, developer options, and there it is. It's actually there now. I'm going to go into developer options, and if you want to turn this off, you can uncheck this thing here, and then you're going to have to click on build number 7 times again to get there. But the things that we want to care about inside here, let's just scroll down a little ways. USB debugging is the first guy here, and you notice how he's checked. Depending on your system, he may or may not be checked to start with, so you want to make sure that he's checked and plugged in. Now this next part I can't actually show you happening, so I'm just going to describe it. I'm actually going to plug in my phone, and after I've done those things, so I'm going to pause for a second and do that setup that I just did. So once I've set that up, I plug my phone in using a USB cable, and what I see on the screen is a little pop-up that says allow USB debugging, and then gives me the RSA key fingerprint of the computer. I'm going to go ahead and check a little option on here that says always allow from this computer, and hit allow. And now that should actually have my phone show up right here under device manager. So we have this type as a physical device. That's my actual phone. Now if I want to see that show up, let me go ahead and stop this one, stop the emulator. If I want to actually see that show on the screen, I need to enable an option called device mirroring. So I'm going to go up to File, Settings, and go down to Device Mirroring. And I'm going to activate mirroring when a new device is connected. And then a little privacy notice coming up here saying, hey, you know, your personal stuff that's showing on your phone might show up on your screen here. And this is something I have to be careful of when I'm teaching, because what I've done with this, I've now put my phone in airplane mode so that I'm not going to get a bunch of messages popping up, you know, either, you know, company secrets or, you know, somebody telling me that, you know, my friend's in town, you know, you don't need to see any of that. So I'm going to hit acknowledge. And then activate mirroring when launching an app on a physical device or launching a test on a physical device. I'm not actually going to do that. That's actually if I was on the device and I actually launched something. I'm just going to leave it as it. And let's go ahead and hit OK. And now if I go over to running devices, let's see, connect and hit, or use the device manager. Looks like he is. I may need to just unplug it and plug it back in again. There we go. So now do you want to share any type of debugging on a private network? I'm going to say yep. And this is my physical phone. Now notice it doesn't have a nice little border around it, but this is actually what I see on my phone right now. And if I drag my finger, you'll see that I'm actually starting to drag up to get my application list coming up. That's working just fine. What I'm also going to do here is turn on finger taps. So if I go down to settings, and I'm going to go to developer options again, and I'm going to scroll down and find show taps. I believe that's the option. There we go. So I'm going to click show taps, and now you'll see that as I move around, there's a little circle here showing where my finger is. So that'll just make it easier for me to demonstrate things in here. Okay, I'm going to swipe up from the bottom here to go back to my home screen. And now I can actually run this application on my device. So I can actually hit run. It'll work on the emulator as well. But we'll go ahead and run that. And this is going to build the application as we see down here at the bottom. Then it's going to deploy it, and then it's going to execute it. And this shouldn't take too long. If it does, I'll cut some stuff from the video itself. Depending on the size of your application, this could take quite a long time. There we go. Now he's launching on the devices, and he's trying very hard to launch on the devices. So it looks like the build was successful. Why is he having trouble? So sometimes things don't work in Android Studio. I'm going to go ahead and hit stop on this guy to cancel it. Oh, it finally ran, huh? Wonderful. Let me go ahead and rerun it just to make sure it's going to go through okay. And I'm actually seeing this on my real phone as well as on the mirror that you're seeing here. And boom, there is my first application. Ta-da! Now for the first assignment, all you're going to do is create a new project and then run it on an emulator, package it up and send it to me. The whole point of the first assignment is just to make sure that your development environment is set up and actually working. Okay. Let's take a look at a couple other things inside Android Studio, just so you have some ideas from where the environment is. I'm going to set a breakpoint on this line here just by clicking on the line number, and then I get this little red dot there. That'll stop there, and then I can take a look at variables. If I want to run a debug run, I click on the little bug up here on the toolbar. And then the debugger pops up showing the stack trace, so we know where we are, and then any type of variables that are available at this point. So we'll see here that we had this parameter name coming in, and that was Android for this function. So you can use this to take a look at values as you're running, and then you can step over lines, step into functions, or if you're in the middle of a function, just run to the end and step out. If you want to see all your breakpoints, you can take a look at this guy. This will show you all your breakpoints, and you can delete them from here if you want. And notice it's gone from there as well. This button temporarily mutes breakpoints so that if you want to make a run without having any breakpoints hit, you can do so. This will stop your application. This will restart your application. This guy here continues from a breakpoint. So instead of stepping from that breakpoint, it'll just keep running again until it hits another breakpoint. Now there's some other views we can have here. This build view shows you the status of the build as it was building, and you'll see here that it was running a whole bunch of tasks in Gradle and everything was fine. The Run tab isn't super useful. It used to actually be fairly useful. It would put up a single error if there was any error when you ran your application. But sometimes there might be some information here that's useful. The big one that you want to look at is this thing called logcat. And this is actually the system log running on your device. And we can print out log messages inside the application and see them show up in here. So if I came into here, for example, and I said log.d for debug, passing in some kind of tag. Now, if you're leaving the log in, you want to have a reasonable tag to look for. When I'm just doing quick logs for debugging, I tend to use just 3 bangs there. I'm going to say in greeting. And now if I clear my log cap by clicking the trash can here, and then I'm just going to run it. I'm not going to hit debug mode. I should see that show up. So we'll go to our logcat, go down to the bottom, and we see here's that tag. And then here's the message that came up in debug mode. I can also further narrow it down by putting in the 3 bangs on this little search line. Okay, yes, I got it. Okay, this is a view that shows any problems in the code. So if there was some kind of an issue inside the code, like in this case, a missing curly brace, you can see that. If you want to actually run the build manually, you can do it here from the terminal. And then if you have version control enabled, you can use this tab here. Let's talk about version control for a second. Notice this little bar up here at the top says version control. I'm going to come down here and I'm going to say create Git repository. And that's going to create a Git repository under this directory. And now I have this option called commit up here. If I open him up, I can check all of my unversioned files, put in a commit message, maybe initial commit, something like that, hit commit, and it committed them. Sometimes you might see it coming up here saying that there are some warnings or some errors that were detected, like this one, 5 errors and 7 warnings. And sometimes that'll actually stop your commit. You may have to say commit anyway. Now, if I go down to this Git view, I'll see that on my master branch here, I'm not sure why I created master. It usually creates one called main. It's one of these things for inclusive language. We've changed over from using master as the name of that branch to main. And over here, you'll see on that branch, we have this initial commit. That's very interesting that it did that, because usually it creates it with main. I will have to put that in as a bug. Now, the reason this is important, if you don't normally use version control, please do. What usually happens is students will be working on their project and things will be going great. Then they'll make some changes and things won't go so great and they can't figure out what they did. Version control can save your butt there. Anytime you hear yourself go, yes, it works, make sure you commit at that point. That way you have a place you can get back to. Because if I came in here and let's say I screwed this up by accidentally deleting that code there. Now you'll notice under the commit view here, it tells me what's been changed. And if I double click on it, I can actually see that difference. And if I want, I can undo that difference by doing this little arrow here for this one specific change, or I can just right click on the file and say roll back to get rid of any changes on that file. And that way I have basically save points where I can get back to when I was in a good spot. If you're not using this at home, I recommend you do. It's really easy to do. You don't have to go to a server. If you want, you can set up a free account on GitHub or GitLab and have a private repository to store things in. If you do that for this class, make sure it's a private repository. I don't want your code sitting out there for everybody in the world to be able to get to. If you're not doing it at work, please talk to your tech leads, talk to your managers, whoever, and recommend strongly that you use version control. You really don't want to make copies of directories. I've been at companies in the past where we literally would make a copy of a directory that we were working on every once in a while, and we'd have like foo.1, foo.2, foo.3, and so on. And way back in the day, because I'm old as dirt, that was necessary. But now we have these nice tools that'll manage this for you. And there's a whole lot more you can do with it. I just wanted to show you just real basic commit there and basic rollback, simple stuff. And so now let's pop over to the other side over here, and we'll see that we have don't want to go to assistant. Well, I could show you assistant. This is StudioBot. It's something that's being worked on at Google right now. And this will let you do some fairly interesting queries. The data behind it needs some work. I mean, it's something that's a work in progress, but it's getting there. But the one that I want to go to, if you come over on this side to more tool windows, and we will come down to Device Explorer. And Device Explorer gives you all the files that are on the device. Once we talk about files in a later section in the class, we'll go into detail on where things are inside of here, but that's how you get to them. To wrap things up, I'm going to take a look at a few settings that I really like to set up inside here. So if we go to File, Settings, once again, if you're on a Mac, it's going to be the Android Studio menu, go down to Preferences. And let's go through a few inside of here. So under Appearance and Behavior, appearance, I already mentioned this drag and drop with Alt press. That's pretty important. If you want to change the font that's used or the size for any of the things that are non-editor fonts, this is where you can change them. You can also change the theme here. And new UI is the user interface you see here with little icons. It used to be a lot busier. They've cleaned it up a good bit there. Let's see. Nothing in there, I think. Actually, I'm going to come up here and I'm going to type camel and go down to Editor General Smart Keys. And I'm going to swap these two. These two options are super, super useful for when you're clicking on things. What I like to do is if I double click, have it select the whole word. And so that's this Honor Camel Humps word settings when selecting on double click. I'm going to uncheck that, which means that if I double click on a word, it's going to select the whole word no matter how many camel cased words there are inside it. Use camel humps words is if I'm using the control key to select. So I like to swap those two, and let me show you what those do. If we go back to the main activity, if I have something that is a multi-word variable like component activity, if I double click on it, you'll see it selects the whole word. But if I use the control key to jump between words, I can hold down the shift key and just select part of it at a time. And if I had the camel hump words turned off, if I hit control on this, it would jump to the beginning of the whole component activity. So those two, I like that combination there a little better. I'm going to come up to File Settings again, and let's set the key map. Now, I'm an old school Eclipse user, and I love Eclipse, and I am completely unashamed to say that. It's a fantastic environment. I still wish Android was being developed inside Eclipse. So I'm used to the key mappings in there, very, very used. It's like super muscle memory. So I always change this to be Eclipse, and then hit the little gear to duplicate, and just change it to Eclipse with my initials there. Then I hit Enter, and boom, I have my own key map that I can tweak. Feel free to use whichever key map you want. You can use the default or whatever. Just get used to the keys there. Sometimes I'll mention keys, which are what I'm pressing. It may be a little different from what you're seeing. There's a couple key settings in here that I like to tweak because they didn't quite get it right. So I'm going to type in move. And this is something I'd recommend you try to find no matter which key mapping you're in. This is move line down, move line up. So I'm going to go to move line down, and I'm going to change that to be alt down. And then move line up, change that to alt up, which is how this worked inside Eclipse. And then I'm also going to go to duplicate, and where it says duplicate entire lines, this one says Control Alt down, which is the key pressing I'm used to. If you want a different key press, please change that. I'm going to hit OK, and let me show you what these do. These are fantastic. Let's say that I wanted to have several greetings display on the screen here. I'm going to hold down Control Alt and press down a few times on this line. Boom, boom, boom. And there we go. It just repeated those. It duplicated them. Really fast way of duplicating. You can also, if you have a block that you want to duplicate, highlight those lines or have the cursor, any part of the lines can be highlighted. Then when you hit Control Alt down, it's going to copy all those complete lines. Now, in order to move things around, let's say that I wanted to make a copy of this thing and move it up to the top here. I'm going to hit Control Alt down, and then I'm just going to hold Alt by itself, and I can move up and down to move that line wherever I want to put it. If I want to move both those lines, just highlight them both, and then Alt up, Alt down lets me move them around there. So this can be a really nice way to move pieces of code around very, very fast without having to do a cut and paste all over the place. I really like those. Let's go back into File Settings again. And underneath Editor, I'm going to go down to Code Style. And one code style thing that might be useful is Visual Guide here. You can change where this little light line is to however many columns you want. And it's going to give you a little visual indication of where that is so that you don't go past it. It won't force you to wrap, but it's kind of a nice pop-up to show you where 100 lines is. Or if you want to use 80 or 120, whatever your style is. Under code style, the most important thing is to go to Kotlin and go to Imports and make sure it says Use Single Name Import. and then doesn't have anything down here for packages to use import with star. This is something I believe this is now the default, but I just want to make sure that you jump in there in case it gets changed at some point. Always double check that. If you want to know why that's important, go to javadude.com. This is my site. And then go to articles and take a look at this article called Import on Demand is Evil. This describes exactly why star imports are really a horrible idea. In a nutshell, if you use this, adding a class to an existing package can break your existing compiling code. I think that's a ridiculous feature in a language, that adding something to a package can break code. It's just bad. I really wish this feature were never introduced in Java. Obviously, this article is about Java, but the same thing applies to Kotlin. Never ever use star imports. It can just cause you so much trouble with code that was working, and then a year later somebody tries to compile it with a different version of Kotlin or different versions of third-party libraries, and the whole world blows up. Okay, so let's take a look and see if there's a couple other little things in here that I wanted to tweak. Live Edit is a very useful little feature here. What I like to do is set this to push edits manually on save. And what this will do is this will let you tweak a running Compose application without having to completely redeploy it. And it can be much faster. So I'm going to change this to say push edits manually on save. And let's see what happens when we run this. So I'm going to run the application. And now if I come in here and I change this to say something like that, and hit Control S, boom, it changes it there on the fly. So it's a really nice feature there. If you're wondering why I'm not seeing two greetings there, it's because I didn't put this in some kind of a layout that stacks these. If I had, for example, said column, and we'll just import him and save it. Now I get both of them. Notice again, my live edit worked for me. Hit Control S to save. Boom, there we go. So that makes, if you're just making little tweaks to the user interface, that works most of the time. If you're changing any type of parameters to functions, it totally won't work. Okay, back to, once again, settings. And if you want to add any plugins, here's where you add them. So if, for example, you're used to using Vim for doing your editing, there is a key mapping for Vim here that works pretty well. Let's see, was there anything else in here? The embedded layout inspector is kind of nice. We're probably not going to use that much, but what this does is it overlays the layout inspector on top of what you see in the emulator here, as opposed to in its own separate window. So it ends up being much, much faster, and you don't have to have a separate window open just to take a look at the layout structure. And I think that's probably the only ones that I wanted to talk about. Okay, I'm going to hit OK there. And that's the basics of using Android Studio. Along the way, I may pop up some new features that I haven't discussed here and talk about them in a little more detail, but those are the basics. Enjoy.